Hello everyone. Today we'll be going through ASA level chemistry portion and the topic is hydrated and anhydrous compounds. This is subtopic from the main topic, which is atoms, molecules and stoichiometry, which is having 8 videos. You will have to go through all these 8 videos to cover this main topic, and you can find these videos in the playlist. So hydrated and anhydrous compounds, this is like an example. First of all, we'll be going through what we'll be going through in this video. What does hydrated actually mean, and how are water molecules involved, and what happens in a dehydration reaction. So first of all, what are hydrated salts and water of crystallization is water molecules that are chemically bonded in the crystalline structure of a compound. They are chemically bonded. It's not just wet. It's not just wet. They are part of solids crystal lattice, and hydrated salts are a salt that contains water of crystallization. Each crystal is studied with the water molecules. Their formula shows the number of water molecules per formula unit. So these are fixed number of water molecules studied there. Example we can take, like for example, copper 2 sulfate CuSO4 will be always having 5H2, and these are the blue crystals if they are hydrated. And then cobalt chloride, which is studied with 6 water molecules, and these are pink crystals. And calcium sulfate is having 2 water molecules, and this is white solid. What are anhydrous compounds? When we remove water, so those are anhydrous, and the substance that contains no water of crystallization, we'll say that they are dehydrated or uh, dry form of the hydrated salt. How do we get them? We are just heating them gently, and we are removing the water uh, from the water of crystallization. We are removing, and it's driven off. And example, we can take anhydrous copper sulfate, which is white or pale gray powder, and anhydrous cobalt 2 chloride, which is CoCl2 with blue powder, and these are in powder form. Basically, whenever we are having anhydrous, they are in powder form, gray powder, blue powder, and in case of others also, we are getting crystals are losing their shape when we heat them, right? So the change from hydrated to anhydrous is often a reversible physical change. How we can reverse this test, and we can use these as test of water also. Copper sulfate 5H2O turning white as it's heated. So its color will change, and it will change to white, and then turning blue again when we are adding droplets of water. So we can write the equation: hydrated will be copper sulfate, we are talking about, hydrated will be blue, and anhydrous will be white, and water will be removed. And keep in mind, this is a reversible reaction. If we are adding water here and we are getting hydrated one, this is anhydrous white portion. When we add water, its color will be changing. Forward reaction, dehydration, when heat is added, copper sulfate water will be removed, and copper sulfate solid will be remaining. It will be in powder form. Next, reverse reaction, if we hydrate, water is added, and again we will get copper sulfate. This is reverse reaction. We can use this as test for water. So anhydrous copper 2 sulfate is a test for the presence of water. If water is present, then color will change. White powder will turn blue, and this is a specific test, not just a dampness. Keep in mind, used in this test, using gravimetric analysis, when we find formula for hydrates and indicate presence of water in reactions, and then we can use is important in storage and preservation of chemicals. Visual color changes used as indicator. how we can calculate the water of crystallization. This is important segment. A lot of times it's coming in exam. So we can find X. This is X number of water molecule, MgSO4, and water molecule by experiment. And we can have another example of copper sulfate also. This is how we can heat and remove the water, and we can do the same calculation for copper sulfate also. So in this way, in this example, we have taken magnesium sulfate XH2O. We will be taking mass of hydrated, which is like, say, for example, 4.92 grams. And when we heat an anhydrous, remove after removing water, it will be 2.40, and we can calculate the loss of water, which is 4.92 minus 2.40, which will be, so water is 2.52 grams. Can convert this number of moles of anhydrous magnesium sulfate. So 2.40 grams, which is anhydrous magnesium sulfate, will be divided by molecular mass of magnesium sulfate, and we will get this many 0.0199 moles. And moles of water, the loss of water is this much, which is 2.52 grams. We will be dividing by molar mass of water, which is 18, and we will get 0.14 moles. So we can check the ratio of moles. 0.14 divided by 0.199, which is approximately 7. So now we can write 7H2O. So this is the ratio which we got, and this is the formula which we have written, MgSO4 7H2. This is over. We are done with the topic. Hopefully you understand each and everything. Again, I'll remind you that you will have to go through the playlist, and you'll have to check all these 8 videos for complete revision of this topic. Thank you very much for watching. Take care. Bye.